How do we find derivative of exponential functions using logarithms? That is what we are going to learn here with few examples. Enjoy the journey of learning with Anil Kumar. I am Anil Kumar. Welcome to your YouTube channel. We provide you with solutions of questions which you really need. As per your request, here is a very beautiful video on how do we find derivative for exponential functions. The three examples which you see here are slightly different from the normal rules you have learned, and that's why it's difficult to get them. Let's begin by understanding what is known to us. If we are given a function which is f of x equals to e to the power of x, in this case, the derivative will be the same function as e to the power of x. And if we are given a function f of x equals to b to the power of x, some other constant, in that case, the derivative is really equal to b to the power of x times ln x, ln b. Correct? So, in both these examples, what you notice is that the base here is kind of constant. The only variable is in the exponent x. However, in first example which you see, what is the question? We are given y equals to x to the power of x. So we have variables on both the sides, and that makes it very difficult. And the same thing you see in the second question, which is y equals to ln x to the power of x, and then we have 5x squared, which is kind of b to the power of x. Perfect. How do we solve these questions is what we are going to look into in this particular video. Strategy is to take log on both the sides. So let's take log on both the sides. In that case, y equals to x to the power of x will now become ln y equals to ln x to the power of x, correct? So ln y is equal to applying the properties of logarithms x ln x. Makes sense. So what we have done is we have split the right hand side, kind of product of two variables, and now we can apply implicit differentiation. Differentiating both with respect to x, what do we get? Well, that's what we are going to see now. And that's how such questions will be solved. So ln y derivative is 1 over y, right? So we get the derivative of the left hand side as 1 over y. We are differentiating with respect to x, so implicit differentiation dy dx equals to. Here we are going to apply the product rule, derivative of x times ln x, right? So which is 1 times ln x plus x times derivative of ln x. X times derivative of ln x is 1 over x. So that's what we get on the right hand side. So that gives us dy dx as our answer equals to, we'll multiply by y. What we have here in the bracket is ln x plus x and x cancel, ln x plus 1. Now, in this case, y is x to the power of x, and therefore we get dy dx as x to the power of x times ln x plus 1. Makes sense? So that is how we'll get the derivative of this particular function. So taking natural log both sides helped us to find the derivative. I hope you've understood the strategy. You can apply the same strategy to question number 2 and then solve it. It'll be a good practice question for you. Perfect. So we'll now solve the second question, which is y equals to ln x to the power of x. Great. Now, well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Our students are right there on the top, getting the best marks. In short period of time, you can learn a lot. So now tell me, what should be the strategy? So we have a variable with an exponent, right? So here you have to take natural log both sides as we did earlier. So we'll have ln y equals to ln x to the power of x, which means it is ln y equals to x times ln x. Now, ln x is like a function of derivative, right? So now we can differentiate both sides with x and do what we did last time, implicit differentiation. So we get derivative of ln y with respect to x is 1 over y dy dx. On the right side, product rule will be applied. So basically the derivative of x, right, which is 1 times the function which is ln x plus x times derivative of ln x. Now derivative of ln x will be 1 over ln x times derivative of ln x, which is also 1 over x. You get the idea. So we applied the product rule and got the derivative of the right hand side also. So that gives us 1 over y dy dx equals to ln x, this is ln x, plus here x and x cancel, we have 1 over ln x. Cross multiplying, we get dy dx as equal to y times ln x plus 1 over ln x. And substituting the value of y, we finally get our answer ln x to the power of x times ln of ln x plus 1 over ln x. Do you see how we could find the derivative of this particular function? So I hope these steps are absolutely clear. The last one is not so difficult. Let's now try the question number 3. Now here we are given y equals to 5 to the power of x squared. Taking derivative directly can help us figure this out. We know the rule, which is if we have derivative of, let me write here, if I have y equals to b to the power of x, then the derivative is b to the power of x ln b. So in this case, the derivative dy dx will be 5 to the power of x squared times ln 5. However, there is one difference, and that is the exponent is not x but x squared. So we need to multiply with the derivative of x squared. Correct? So that gives you the answer, which is 5 to the power of x squared ln 5 times this derivative is 2x. And so we get our result in this particular case that dy dx is 5x squared times 2x ln 5. ln 5 we can write as it is because that's a constant, right? And 2 is also a constant. That would be fine. So that becomes the final derivative for the third part where we have directly applied the rule. I hope it makes sense. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.